Hello, everyone. Today we're going to talk about Java generics as part of lesson 11. This is the last lesson for the course. First off, introduction to generics. We know prior to Java 5, when you have to store a list of items or some data items into a list, you treat them as what? As objects. So you just say list words equals new array list, and then you say words add. In this case, we add a string hello, and then we add another one, world. So when you read these items from this list, and you have to cast it specifically by saying string words that get 0, or string words that get 1, before you can print it. But since Java 5, after the introduction of generic parameters, what we can do is this. So instead of saying list of words, we say list of string words. Then you can add words.hello, words.add world. And then the difference is when you read these things from the list, you automatically get a string. You don't have to do casting. Okay. So what are some of the benefits for generics? The first one is obviously we get stronger type checks at compile time. So if you use the raw type, and the compiler is not helpful to check the types for you. But with the generic type, with the generics, the compiler knows exactly what data type these items are before you add or when you read. So you get support from the compiler. Yeah, getting support from the compiler is always better than relying on the runtime environment to check the types. Another one, reduced downcasting. What does that mean? We just saw from the previous example that when you read a data item from the list, and then you have to specifically cast it back to a string. So this is called anti-pattern in the industry. Downcasting is considered an anti-pattern, which is a bad practice. So the message is the message you pass to tell the compiler is, I know what I'm doing, and I want to cast it back to a string. Relying, the rule is relying on humans rather than on the system is not always good. It's not always a good idea. So with the introduction of generics, we totally get rid of these unnecessary downcasting or casts, which reduces the odds of making human mistakes. Now, by the way, another thing, just take a look at this example. Suppose we have the superclass closed curve, and then we have concrete subtypes like triangle, rectangle. So when you store triangles and rectangles into an array of closed curve, we don't have to tell the compiler, the runtime, what exact type each element has. When you read it from the array and make a method call, the Java runtime environment automatically makes sure that you get the correct method invocation based on its actual type. So we should rely on something like this instead of relying on humans. Another benefit, if we look at these two methods, we see that method 1 only works for integers. When you loop through a list of integers, you want to find the max value. But the second example down here, it says I can work on a list of t's. T here means that's a type variable. It can be any type. But the restriction is this type T has to be a subtype of comparable. That means whatever item T is, and we should be able to compare those things. So integer is comparable, or integer implements comparable integer, or float implements comparable float, and also for double, for character, for longs. Other than these, so any type that implements this comparable interface can be stored in this list, and then we can use the same method to find its max value. So the second one is obviously a lot more flexible than the first one. Some generic terminology and naming conventions. We see the class array list of type T down here. So this is called a generic class because the declaration of array list involves using a type variable T, and T can be any object, can be any reference type available in Java. Okay, so T is also called a type variable or type parameter. So over here we see a list of string words. We give it a nice name. We call it a generic type invocation. Okay, this is not really that important as long as you know when you hear somebody say a generic type invocation, you know what they're talking about. But a type argument is this string. In this case, that is a type argument for the list. Okay, and the list of string is called a parameterized type. So compared with a list without specifying a type argument, that is called a raw type. Notice some difference here between the term generic class and a parameterized type. So the previous slide, array list of type T, that is a declaration of generic class. But over here, a list of string, this type is called a parameterized type. So there's a difference. Okay, generic class, that is a class declared with a type variable T, and a parameterized type is a collection type with a type argument that has an actual type, like string. You know, from Java 1 on, if you still use raw types without using a type parameter, the compiler is going to give you a warning because it cannot do type checks if you don't provide one. Here's some commonly used type variables. E, the capital E, that stands for element, and K for key, N for number, T for type, V for value. If you need more variables, you can use SU and V as your second, third, and fourth type. Now, how do we create our own generic class or interface? It's not that different from creating a regular type class or regular interface. The thing we need to have is we have to declare the type variables. For example, in this case, we are declaring class simple pair with two type variables, K and V. So over here, key is of type K and value is of type V. These are just like, attributes you would declare for any regular Java class. In the same way, you can write your constructors, you can provide your getters and setters. For example, you see here public K, get key. So the return type is of type K, which is a type variable. The class declaration introduces these variables. You have to put them into a pair of angular brackets or chevrons after the class name, simple pair. So when you have to create a real object of type simple pair, and you have to give actual types for K and V, you cannot just simply use type variable K and V to declare, to create an instance of a simple pair. So let's see this example, simple pair of integer and string. So you can create a new simple pair with an integer, 10,123, and a string gem. Okay. How to implement a generic interface? So imagine we have declared an interface called pair with variables k and v, and we have two abstract methods, getKey that returns a type k and getValue that returns a type v. So when you implement it, we have actually two options. The first one, we create a parameterized type, or parameterized class that implements this interface. For example, this class myPair implements pair string integer. So at this time, you have to give actual types like string and integer. A second approach is you just create a generic class that implements this interface. So you have to retain these type variables k and v, and the rest of the stuff is pretty much the same as what you have to do for the previous class. How to extend a generic class? We are going to create myList T extends ArrayList T. So this remains as a generic subclass because we still keep the type variable T. But if we create a parameterized type subclass, and we can say public class myList without type parameter over here, myList extends ArrayList of string. So string is a parameter, is a type parameter for this myList. Now let's sit back and think about how Java implements type erasure. So what that means, when you have a piece of code with generic types or with parameterized types, and then you compile it. When you do this, the Java compiler actually erases all the type information from the source code, and then you get exactly the same code as you would do for the pre-Java 5 version. So you don't have parameterized types. So this is called type erasure. That means the Java compiler, when it compiles your code, it removes all the type information in generic types or in parameterized types. So why would Java want to do that? Imagine we don't have it, okay? We don't have type erasure for Java. So every type, like list of string, list of employee, list of anything, would be a different type. So if that is the case, Java would end up having so many different types. Actually, in C++, this is the way it works. So every parameterized type is actually a different type. Maybe the Java developers or Java designers think that's not a good idea. So let's use type erasure so that we have a much smaller number of types in Java. And another thing, or another benefit for type erasure is we provide backwards compatibility. So before Java 5, we used to use raw types, and after Java 5, we use generic types or parameterized types. But once you compile it, you get bytecode. They're actually the same, okay, with all the type information removed. And this is how Java implements or supports generic types or parameterized types. But the way that Java implements generics is not that intuitive, or it's unintuitive. For example, so this manager is a subclass of employee, but let's see, an array list of manager is actually not a subclass of an array list of employee compared with arrays. So we say generic subtyping is not covariant, meaning that manager is a subtype of employee, but a list of manager is not a subtype of a list of employee. So this is not covariant. But Java arrays are covariant, meaning if manager is a subclass of employee, then an array of manager is a subtype of an array of employee. Okay, that's a little bit confusing, but there's a reason for that. So if you see this, in this example, or it's not an example, it's an exercise. Let's see this piece of code. So we have a list of integers, and then we add 1 and 2 into the list. So if a list of number is a supertype of a list of integer, we can do this, right? Nums equals ints, because ints is a subtype of nums. So if we could do that, and just imagine a list of number, I can always add a float or double. So if that is the case, you're actually allowing a list of integers to contain double and float numbers. So do you think that's a problem? Yes, of course. That would cause runtime exceptions. So this is a diagram that shows this covariance or non-covariance. So manager is a subtype of employee, and then an array of managers is a subtype employee, array of employee. But the list is not covariant. So manager as a subtype of employee, but a list of manager is not a subtype of list of employee. Another thing that is not so intuitive is the component type of an array is not allowed to be a type variable. So we can say that T array of T is null. This line compiles. But when you have to really create an instance by saying ARR equals new T5, that means you want an array of T with size 5. This line does not compile. Okay, interestingly. There's a workaround. If you're interested, you can take a look at the demo code. But the solution is actually based on Java reflection. So you cannot directly say new T with a size, but you can use Java reflection to create an array of T. Another one. Component type of an array is not allowed to be a parameterized type, meaning that if you have a list of strings, and then you want an array to have items of this type of list of string. So when you say list of string array equals new list of string array 5, what do you get? You get a compiler error. Okay? Java simply, or the Java compiler does not allow you to do this. So the problem is, or the question is, why? Why would Java want to do this? So this has something to do with, we call it reifiable type. So what does that mean? Reifiable means, so anytime you have a type, you have a class, you have parameterized type or generic type, but when you compile it, you erase the type information. So if the type is reifiable, that means the type information is completely represented at runtime. Okay, so this is what it means by being reifiable. But we know Java does type erasure when the compiler sees generic types or parameterized types. So that means the compiler would remove type information when it does compiling. So at runtime, you lose information on the types. So that means Java generic types or Java parameterized types, these are not reifiable types. So therefore, you cannot create an array of non-reifiable types, which is the rule for Java arrays.